Bro, what are you doing? I'm using a telescope to look at all the dinosaurs. How? See, the telescope is like a time machine. I'm trying to see into the past and see what the earth was like when the dinosaurs were still around. Okay, 3 things. 1, that's not a real telescope. 2, it may be a time machine but not the way you described it. And 3, what the hell are you looking at? You're indoors. There's not even a window there. Okay, so what can you do with a telescope? Hi, my name's Pranav and you're watching Science is Dope. If you haven't guessed already, this is the story of the telescope. It's a story of how one instrument not only helped us see things outside the earth far away, but changed our understanding of how things worked in the universe. It's the one instrument that improved our knowledge probably more than any other. We're going to look at the various stages in the evolution of the telescope, starting with what Galileo used and how that helped eliminate all these superstitions that people held, all the way to today's massive telescopes and how they peer into the universe's past like a time machine to see its first moments. So let's begin. First, we have to start with this is Aryabhata, 5th century astronomer from India observing the stars. His contributions to the world of astronomy are immense. He composed the Aryabhata, which spoke about the shape and rotation of the earth, the nature of stars and planets, solar and lunar eclipses, etc. And he did all of this by observing the sky with his naked eyes because the telescope hadn't been invented back then. You can find out more by watching this video I made extensively about him. I'll leave the link in the description as well. Astronomers of this time accomplished a lot of things with just naked eye observation of the sky. They named planets and stars that they regularly observed. They noted the patterns these stars made in the sky, what we call constellations, and they tried to understand why they saw certain stars and planets moving the way they do. But their knowledge was limited. They only knew about a few of Earth's neighbors, the planets and the brightest of the stars. This, along with their tendency to believe in the supernatural, meant they would often come to the wrong conclusions. For example, they saw that when winter came, the birds would migrate towards the south, and at the same time they would notice that these particular constellations were up in the sky. So they concluded that the two must be connected, and they started thinking that the stars in the sky have some influence over the behavior of creatures and the happenings here on Earth. They didn't know that the changes in seasons were not caused by the stars, but instead by the tilt of Earth's axis and the position of Earth around the Sun. They equated correlation with causation. Another example for this is how people who faced tragedy, they would look up in the sky, see comets in the sky, and make up their minds about how if we see a comet in the sky, then some tragedy was gonna happen here on Earth.
One of the men talking about the comet said it's an omen.
But a comet means one thing, boy. Dragons.
These ideas and many more like this gave birth to astrology, predictions of what would happen to people based on star position. All of astrology was developed in this era, before the telescope, before we had the tools to make good observations, and before we had the scientific and logical know-how to make the right conclusions from what little we did see. But all that was about to change in the 1600s. When most of Europe was immersed in war, a young German moved to the Netherlands and started working as a spectacle maker. He made an instrument that became famous as a spyglass. He claimed that it could be used to see things far away as if they were nearby. Today we call this instrument the telescope, and this young German was Hans Lippershey or Hans Lippershey. Different sources have different versions of his name. The news of this invention spread throughout Europe, getting scientists like Galileo Galilei interested. What the military used to plan attacks, Galileo turned it towards the sky to seek answers. And that's when we started to really understand the universe. Galileo observed the moon closely, and he was able to understand that the dark spots on the moon were actually shadows. People back then believed that the moon's surface was a perfect pearl, but now it was evident that the moon's surface was not perfectly smooth. There were mountains and valleys and craters. Celestial bodies were not godly and perfect, they were just like the Earth. And there was another myth he debunked. Back then, most people believed that the universe was geocentric, that is, the Earth was in the center and everything went around it. But not everyone agreed. A small group of people thought that the universe was heliocentric, or the sun was at the center and everything went around the sun. And Galileo was one of them. So he started using the telescope to see what was really the case. And he got his answer when he started observing Venus. He saw that not only did Venus have phases like the moon, but the planet's size also changed depending on which phase it was in. Close to a full Venus, the planet would look smaller compared to when it's a new Venus. All this could not be explained if Earth was at the center of the universe and Venus went around Earth, because then the different phases would be the same size. But clearly, if there was such a huge difference in size between the phases, then Venus was going far away from the Earth at some points in its orbit and coming close by at some other points. It could only be explained if both the Earth and Venus revolved around the Sun. This became a major piece of evidence supporting the heliocentric theory. The Earth had to be going around the sun. But how can a planet drag another celestial body with it? I mean, if the Earth was moving, wouldn't it leave the moon behind? This was another argument against heliocentrism, and Galileo found the answer when he looked at Jupiter. What he noted were a few small planets close to Jupiter, and these planets would sometimes disappear as if they were going behind Jupiter, as if these planets were going around Jupiter. And that's when he realized that they weren't planets at all, they were the moons of Jupiter. And these four came to be known as the Galilean moons of Jupiter. But here was the conclusion he made. If Jupiter could go around the sun carrying all these moons with it, why not the Earth? Okay, so planets and their moons went around the sun. But people didn't really understand why that was the case. It was a few more decades before Newton came up with gravity. But despite that, with this new instrument, anyone could look up at objects in the sky or the heavens or the house of the gods, as some people called it, and see that they were no different than the Earth. People began letting go of beliefs and superstitions that they held because of things they couldn't understand, because now they could. The coming century saw the discovery of more planets and moons and other objects in the solar system. Uranus in 1781, the asteroid belt in 1801, Neptune in 1846, and Pluto in 1930. None of these discoveries could have ever been made by anyone without using a telescope. But that's nowhere near the end of the story. So far, we've only been able to observe till Pluto's orbit. But what lies at the edge of the solar system and what lies beyond it? There were some leading theories, but to find definitive answers, we needed to observe. The telescope had to get bigger and much more powerful. Let's say you have a white disk with two black dots on it and you hold it far enough away. The light coming from them will form an image on the retina of your eyes. Your retina is like the sensor of a camera with little dots or pixels sensing, each one sensing what light falls on it. And if the light from both the dots fall only on one pixel, then you'll see the white disk as having only one black dot. This is the same reason why you can't read letters on a page that's held far enough away. Because your eye can't separate out the details of the page because light from different parts of the page might be falling on the same pixel in your eye. Now let's use a telescope to look at this disk. What the telescope does is it spreads out the light rays coming from the object before it enters your eyes. And now all these light rays fall on a greater number of pixels in your eye. So all the details that you're looking at doesn't get squished together. Now that everything is falling on different pixels, you will see two black dots on the disk. Remember, the disk is still far away, but you end up seeing a lot more detail. So this is what a telescope does. It doesn't bring things or let you see things as if they were closer to you. It basically spreads the image over multiple pixels and lets you see more detail. And this process is known as increasing the resolution. You might already be familiar with this idea. See the settings button below the video, click on that and you can increase or decrease the resolution of this video. A low resolution means a blurry image and a higher resolution means a crisp, clearer image. And it happens for exactly the same reason. When you increase the resolution, you're basically increasing the number of pixels in the video, in the image, thereby letting you see with more clarity, with more detail. To make a telescope with a high resolution, you needed to be able to collect as much light as possible. In other words, make them really big. In 1919, a young astronomer joined the famous Mount Wilson Observatory in California. And around this time, the construction of the world's largest telescope at the time was also completed here, the Hooker telescope. I know that name sounds weird, but it was named after the guy who financed it, John D. Hooker. The discoveries that this young astronomer would make with the telescope over the next decade would go on to revolutionize the views of scientists once again. Who was he? None other than Edwin Hubble. He would go on to discover two things. First, the telescope he used was so powerful that it could resolve single points of light in the sky that we initially thought were stars and show that they were actually entire collections of stars, entire galaxies of their own. Until that time, we used to think that the entire universe was composed of only the stars that we could see in the sky, and we could only see stars from the Milky Way galaxy. He was the first person to show that the universe was much bigger than just a galaxy, that there were galaxies outside our own, outside the Milky Way. Second, he showed that these galaxies were moving away from us. In other words, the universe was expanding. This is one of the major evidences in support of the Big Bang model of how the universe began. Every time there was another major revolution in the telescope, there was a major revolution in our knowledge and understanding. One thing was for sure, the telescope was the way to go. So what's the next stage in its evolution? How about launching telescopes into space? Sounds cool, but why? Because if we have a huge telescope kept somewhere on Earth, we can only look at the sky directly above it. Moreover, things like clouds and mountains and smoke and fog, they prevent us from getting a good look at the sky and making good observations. And there's more. Even on a clear night, the atmosphere makes stars twinkle and makes them difficult to observe. The atmosphere also treats different light coming in differently. Visible light is generally allowed in, but X-rays and gamma rays and UV rays don't come in the same way. Unlike us, telescopes can see outside the visible range. We can tune them to look at any part of the spectrum of light. But to look at other forms of light and to look at any part of the sky, telescopes have to be launched into space. In the middle of the 20th century, when the world was just healing from the horrors of the World Wars, some scientists began work on a project called the Large Space Telescope. In 1990, after decades of waiting, this project, which later developed into the Hubble Space Telescope, was finally launched. This space telescope was so ahead of its times that it's being used even today to make observations. And it has made so many observations that researchers have published like 19,000 papers just from observations using this one telescope. One of the most important discoveries of this telescope was the fact that it confirmed that there was a black hole at the center of most galaxies. Until then, scientists debated over this, but the Hubble telescope confirmed it. Another important discovery was the rate at which the universe was expanding. Edwin Hubble had already told us that the galaxies were moving away from each other, but we didn't know exactly how fast. And now, using this telescope named after him, we were able to figure out how fast this rate of expansion is and the age of the universe. We discovered that it's 13.8 billion years old. And the amazing photographs that the Hubble takes is just a cherry on top of all the amazing discoveries it's made. But if we can do so much with just this, imagine what we can do if we had a more powerful telescope. Remember the beginning of the video that had this idea of telescopes being like time machines? Here's how that works. Everything has a finite speed of traveling. Like if your friend throws a ball towards you, then the ball reaches you a few seconds after it leaves your friend's hand. Light has this finite speed too. So when you look at your friend, you don't see them as they are now in the present, but as they were tiny fractions of a second in the past. When you look at the moon, you see it as it was 1.3 seconds ago. When you look at the sun, you see it as it was 8 minutes and 20 seconds ago, because that's how long light takes to reach us from those bodies. Now, light is faster than anything we know, 3 lakh kilometers a second or 300,000 kilometers a second. Still, it takes light about 8 minutes, more than 8 minutes to reach from the sun till here. That's how far apart things are in space. If you use kilometers to measure distances in space, it'll be like measuring the width of the country using inches. So we use a new unit of distance, the light year. It's a distance that light travels in a year. The nearest star to the sun is around 4 light years away. That means light from that star takes about 4 years to reach us. Which means when we look at the star, we are looking at something that was 4 years old. Now let's see how far we can take this idea. We know that the universe is 13.8 billion years old. What if we built a telescope powerful enough to see that distance away in light years? This is where the James Webb telescope comes in. It was launched just recently, you would have seen it in the news. It's named after a former head of NASA, and it's so powerful that using it, we are literally seeing the moments right after the universe was born. Now when I say right after, I mean like 100 million years after, but no telescope has seen what the James Webb telescope is gonna see. Its observations are gonna tell us whether the theories we have about the early universe, how accurate their predictions are. We might also learn something new that might change our understandings of things, just like all the major telescopes before it. But for that, we'll have to wait and see. It's just amazing that all of this is happening during our lifetimes. As I make this video, the James Webb telescope is set to release its first images on July 12th. I can't wait. See, the way we progress in science is simple. We make some observations and form some theories based on that. Now, these theories may be right or wrong, and we learn that by observing and testing whether things in the world actually match our theories. And the story of the telescope is probably the greatest example for that. Now, this is the simplified version of how science works. If you want a more detailed version, I've got an entire playlist on my channel. Feel free to check that out. Before the telescope was invented, the leading theories about the universe were geocentrism and heliocentrism. The observations that Galileo made with the telescope verified heliocentrism and falsified geocentrism. The same way, we used to think that the universe was static until Hubble showed that it was expanding. We'll just have to wait and see with things like the James Webb telescope which parts of our knowledge will be confirmed and which parts we'll have to change. I'll see you in the next one. Till then, remember, science is dope.